Okay, so here is video L5, and I'm going to do two examples. So what is the particular solution to the differential equation right here with the initial condition right here? Okay, so this initial condition is telling you that pi over 2, 0 is a point on the original graph. So this would be the x coordinate, that's the y coordinate. All right, so first I'll cross multiply. So dy is cosine of x 1 plus 3y dx. Then I got to get the y's on this side, so I'm going to divide both sides by this binomial. So this is 1 over 1 plus 3y dy equals cosine of x dx. Okay. Then what you've got to do is take the antiderivative of both sides. So that would be an integral. I was going to use a different color, but I guess I'll use this. All right, so we're going to do the integral of the antiderivative on both sides. An antiderivative is the same thing as an indefinite integral. So that's without the numbers on the end. So this is not area under the curve. That would be the numbers on the end. Okay, so now for this antiderivative, so if you've got a situation like this, you want to try to do f prime over f. So I'm going to do a little aside. And if I let f equal 1 plus 3y, then f prime is 3. So I want a 3 up here. So I can multiply by 3 over 3. That would give me a 3 up there. And then the bottom 3 I would just take out as like a 1/3. So I multiply by 3, and then I'm going to have a 1/3 out there. All right, now this is f prime over f, so I can bring down the 1/3, and then the antiderivative is natural log of the absolute value of 1 plus 3y equals antiderivative of cosine is sine plus c. Okay, so we've done the antiderivatives. Now we've got to find c by using this initial condition. So I'm plugging in for x and y. So this is a 1/3 natural log, absolute value of just 1, is sine of pi over 2 plus c. Sine of pi over 2, all right, that's where pi over 2 lands you. Sine is the y coordinate, so this is 1. This is 0. Natural log of 1 is 0. So that's 0 is 1 plus c. So c is -1. So now I plug c back in there. 1/3 equals sine of x minus 1. Now we've got to solve for y. Okay. So I'm going to divide both sides by a 1/3, okay? And then when I do keep change flip over here, that's like multiplying by 3, or dividing by a 1/3 and multiplying by 3. So this is, and if any of the algebra that I do, if you're confused about it, you've got to figure it out, okay? So, and figuring it out could be asking me like how I got something, but you need to understand every step here. Okay, now how do you cancel a natural log? You put it inside of an e function. So on both sides, I am going to, we did this last year, okay, so not that you should remember it perfectly, but just so you know. You've done it before, so somewhere in your brain. All right, so I'm putting a base of e on both sides. On this side, though, these are going to cancel. So I got absolute value of 1 plus 3y is e to the 3 sine of x minus, yeah. Okay, now, another thing that we did do last year, okay, just so you know it's not completely new, is we got to get rid of the absolute values. So to get rid of absolute values, you just do plus or minus on the other side. So I can drop the absolute value bars if I say plus or minus e to the 3 sine of x minus 3. Now, so we're going to use initial condition. Use initial condition to figure out whether it's plus or minus. Okay, so when the initial condition is that for an x value of pi over 2, we want a y value of 0. So, so I'll do like an aside here. So 1 plus 3y equals, let me try the positive one, e to the 3 sine of x minus 3. Let me try the positive one and see if this initial condition works in it. So if I plug 0 in for y, I get 1 equals e to the 0. 1 equals 1. Okay, so that checks out. Now let me just test the negative one and make sure that it doesn't work. 1 plus 3y equals negative e to the 3 sine of x minus 3. That would be 1 equals negative e to the 0. That would be 1 equals negative 1. So that one is not true. So this aside is telling me that it's the positive one. So 1 plus 3y equals e. So you're doing two things with the initial condition. You're using it to find c, and then sometimes you use it again at the end to figure out if there's a plus or minus situation to figure out which it actually is, the plus or the minus. Okay, now I just solve for y. So I've got y is equal to e to the 3 sine of x minus 3 minus 1 over 3. Okay, so that is the answer right there. Okay, I'm going to do another one. This is going to involve having to use u substitution for an antiderivative. So what is the particular solution to this differential equation with this initial condition? Okay, so, all right, so this is going to be e to the 2y, is that a plus or a minus? Oh my gosh, I can't even tell. Let's just say it's minus. Shoot, actually, let me look real quick. See if I could see better on our document. Yeah, it looks like a minus. Ugh, kind of looks like a plus. All right, let's just do minus. 2y minus 4 dy equals 3 sine of x dx. Ah, can you see? All right, then you've got to do the antiderivative on both sides, but for this one we need u substitution. So we're going to let u equal 2y minus 4. So then du equals 2 dy. Careful, I did it the first time and I said 2 dx, but it's dy that we're trying to replace. So dy is a half du. Okay, so then we've got the integral eu a half du. Integral 3 sine of x dx. I could pull the half out front. E to the u du. Okay, antiderivatives. So I can bring down the 1/2. Antiderivative of e to the u is e to the u. Antiderivative of sine is negative cosine. Co-negative. Excuse me. Plus c. All right, now let me plug the u back in. E to the 2y minus 4. All right, and what this initial condition is telling us is when x is 0, y is 2. All right, so I use initial condition. Use initial condition. So I get 1/2 e to the 0 is -3 cosine of 0 plus c. All right, so 0 is right there. Cosine is the x-coordinate, so that's 1. E to the 0 is also 1, so that's 1/2 -3 plus c. I think I'm doing it right. Oh, I never took the antiderivative when I did it earlier. Okay, so I've got to add 3 to both sides. So c is 1/2 plus 6/2, because 6/2 is 3. C is 7/2. Okay, so I'm going to put the c back in. 1/2 e to the 2y minus 4 is -3 cosine of x plus 7/2. And then you've got to solve for y. So I'm going to divide both sides by 1/2, which is the same as multiplying everything by 2. So we get e to the 2y minus 4 equals -6 cosine of x plus 7. Now, this time we've got to cancel an e. So how do you cancel an e function? You put it inside of a natural log function. So you could take the natural log of both sides. So natural log of blank equals natural log of blank. So e to the 2y minus 4, -6 cosine of x plus 7. So these cancel, and you've just got 2y minus 4 equals natural log. Okay, and then I've got to add 4 and divide by 2. So y equals -6 cosine of x plus 7 plus 4 all over 2. And that is the answer right there. Okay.